Okay, the complement to adding polynomial fractions, its partner subtracting polynomial fractions. There is a little bit of a trick to this one, making it different from the adding ones. That is, anything that is behind this minus sign has to change its sign. It's always important to remember that rule. That minus is referring to everything that follows behind it. A lot of people make the confusion by just sticking it on the first thing, but that's not true. This is really 6 minus 3x minus 4. And that minus applies to both the 3x and the negative 4. You have a common denominator here, so you can keep it. But when you perform the operation to the numerators, 6 minus this entire binomial changes what's inside, because once you go through the distributive property, you have to remember that's really a negative 1 in front. You end up with 6 minus 3x, but then plus 4. The 6 and the 4 combine to make 10. And there's your answer. This becomes more of a complicated process the more complicated the polynomials get. The one on the left, for example, is a trinomial. And whenever it comes to these trinomials, I always like to use the factored version of them, if there is one. This makes things easier later on, because oftentimes you'll find something that can cancel with something at the bottom, and that makes the whole process a lot simpler. I do know that there are two numbers that can multiply to make 28 and add to make 11. That would be 7 and 4. I know the signs are the same. They both have to be plus. So the factored version of x squared plus 11x plus 28 is x plus 7 and x plus 4. The rules from last time are the same. If the denominators are different, which they are, you can make a common denominator by just multiplying the denominators. So as I draw a new fraction here, I'm just going to show that this factored version of this polynomial has to multiply this binomial. So I'm just going to draw all three of those. X plus 7, x plus 4, x plus 7 a second time again. That's what's happening to create the common denominator. But then you must perform cross multiplying to change the numerators. The 3 has to multiply x plus 7. I'm going to show that. And then I have to remember that the minus sign, the operator sign, goes here in the numerator, and it's about to separate groups. Group 1 on the left and group 2 on the right. That's going to come from 10 times, technically this polynomial, but I'm going to use the factored version, 10 in front of x plus 7, x plus 4. When they're separated into groups in your numerator, group 1, which consists of 3 and x plus 7, and then group 2, which consists of 10, x plus 7, and x plus 4, this is a process called factoring by grouping. If there's something that's common to both groups, you can pull that out. Like x plus 7 is in both group 1 and group 2, so I'm going to write him to the outside up here of a set of brackets. And I'm going to ask myself, once I take x plus 7 out of both groups, what am I left with? Well, in group 1, once I take out x plus 7, I've got the number 3. And that's it. After that comes the minus sign. Remember, I took that out. What's left in group 2, after I pull out x plus 7, is the 10, as well as the x plus 4. Being able to pull that x plus 7 out of both groups allows me to cancel it with one of the x plus 7s in the denominator. Now I just need to perform the operations to the numerator, denominator, combine like terms, etc. I've got 3, and then I've got negative 10 that is supposed to multiply through that parentheses. So 3, negative 10x, negative 40. If you think about what we were talking about earlier about changing the signs, 10x plus 40 turns into negative 10x minus 40 when you consider that negative sign there. If you just distributed a 10 and change their signs, you end up with the same thing. The 3 and the negative 40 are like terms, so I get negative 10x minus 37 as my numerator. The denominator, I need to multiply x plus 4 and x plus 7. That would give me x squared plus 7x plus 4x plus 28. Like terms here. We get x squared plus 11x plus 28. As we talk about multiple times in class, that is not the only way to do that question and come out with that answer. You will see one of these on the test, so I definitely recommend watching this video, studying as many of these as you can. There's probably only going to be one that's this difficult. But study it, be able to get it. Catch you next time.